Hey everyone, this is Scott coming to you from Pivot. I wish I could say I was reporting to you from a trade show, as it may look like, but this is an image of a tabletop that we had at a trade show sometime back. I thought I'd use it for effect, but more specifically, I wanted to talk about Chromanik Technologies, a close partner, and their bonding technology in relation to LCMS. We were going to exhibit at ASMS back in June, and unfortunately it was changed to a virtual show, which turned out okay. We were going to have a booth and a poster, and we were still able to exhibit on a virtual level and show our poster as well, and got some good feedback. So I'm going to transition into a screen share and show you this poster. Just bear with me 1 second. We're going to get rid of some of the notifications that may be in the way. Move this over here. And here we are. So again, this is HPLC and HPLC columns for LCMS. There we'll highlight the Sunshell, which is the Chromanik brand's, Sunshell, which is the coreshell technology, and the Sunniest is the fully porous material. I have some notes here as well, which I will refer to help make this presentation move forward. So jumping right in here with the poster, we will talk about the double end capping technology, as well as the high temperature end capping. And what these bring are the following: low bleeding and high stability. Let's jump into this here a little more. So if I can, yeah, here we go. I'm going to expand it and move it around a little bit, and so hopefully you can see it more clearly. So the end capping is with hexamethyl dichlorotrisilixane and TMS on C18 silica. TMS is trimethylchlorosilane. And the end capping reagents move like a geometric caterpillar, as noted in the pictures, so that a functional group on the tip of the arm can bond with a Xylenol group, which is located throughout. And we call this end capping method the Sunniest double end capping. We talk about heat as well. And so just looking at this with a typical no end capping C18 column, you will see Xylenol groups. The blue ovals are hydrated Xylenol groups, which do not have much of an influence, and they act more like an ion exchange. The pink ovals are the non-hydrated Xylenol groups, and they absorb basic compounds and influence hydrophobicity. But in the case here, we talk about the Xylenol activity control technology, which is the Chromanik technology here. And this involves heating of over 200 degrees Celsius. And what happens here is it causes the silica gel to become amorphous. And as a result, the Xylenol groups combine to form a siloxane bond. And as a result of this, you do not see the non-hydrated Xylenol groups here. And they do not absorb basic compounds. So we'll highlight it more here as well. So if you look at the two types of end capping, you have a conventional end capping, which has the pink non-hydrated Xylenol groups, as you can see. And so the non-hydrated Xylenol groups contribute as a polar site and make hydrophobicity of a stationary phase decrease. But if you look at a Sunniest double end capping and Xylenol activity control, you see, as noted here, you see more of a siloxane bond and less of the non-hydrated Xylenol groups, which in effect make the Chromanik columns more hydrophobic. Move this down here to speak about stability under acidic pH conditions. So if you look at this in more detail, we're using a Sunshell C18 2.6 micron, 2.1 millimeter ID, and a 50 millimeter length using a mobile phase 0.1% trifluoroacetic acid, a pH of 2, and acetonitrile. And if you look here at this stability, you can see even up to the 10,000th injection, you see the peaks remain consistent and stable. Moving to the right with the bleeding test using LCMS, we also again use a Sunshell 2.1 millimeter ID with a 50 millimeter length, and we're looking with a mobile phase of 0.1% acetic acid and acetonitrile. The Sunshell is the blue in the blue, and the comparative column is in the red. And as you can see, you're looking at the ion chromatogram, and this is a mass spectrometer, looking at a sample between 6 and 8 minutes. You can see that the Sunshell column fares quite well compared to the comparative column in relation to bleeding. Now, what about applications? So one application we looked at is the simultaneous analysis of pesticides with LCMS. Again, using a Sunshell column, 2.1 millimeter ID, 100 millimeter length, with a mobile phase of 0.5 millimolars of ammonium acetate in water and 0.5 millimolars ammonium acetate in methanol. And as you can see, the results are quite positive. Moving to the right, we also look at the IDA measurement using a Sunshell C18 2.6 micron. It's a 0.075 millimeter ID and 150 millimeter length. And this is a nano LCMS. The sample is a triptych digest of BSA with 30 micrograms on column. And you can see after verification with the database, the sequence identification rate of BSA was over 60%, which was a higher identification rate than conventional nano columns. Again, these are just some. We also have various other applications as well. So we want to highlight again the bonding technology, with the double end capping, the Sunniest double end capping. We also want to highlight the changeover of the Xylenol groups to the siloxane bond, as well as the stability under acidic pH conditions. I'm going to stop sharing here. If you have any questions and feedback, we'd like to hear from you.